Hey guys, what's up? I know, I look different. I look clean. And look at this. Who's this lady?
Every once in a while I show up.
Alright guys, so today's lesson is going to be on volcanoes. This week we're going to be doing volcanoes, plate tectonics, and then we're going to do a lab on Wednesday. So please make sure that you're paying attention. And we will catch you guys later.
Bye guys, miss you.
All right, so if we're going to talk about volcanism, well, we need to talk about volcanoes. What's our definition? So a volcano is defined as a mountain or hill or fissure. Fissure is a crack, an opening in the crust. Okay, now a lot of the hills or mountains tend to be conical. They're shaped like a cone. Okay, they have a crater, which is a large depression at the top with a hole in it that we call a vent. And from this vent, you get lava, rock fragments, hot vapor, gases coming out from inside the earth, from the crust and below. When we talk about volcanoes, we usually use the term active, meaning that they're currently going off, dormant, which means that they haven't gone off in a while, but we think that they could still, or extinct, meaning that they have completely and totally run out of magma, lava, and no longer will go off or pose any sort of threat. All right, guys, so just to give you an idea of what's actually been going on, this is the Smithsonian and United States Geological Survey's website. Okay, you can see the address right there. And this shows you the activity for this past week. So if we look here at this picture, these are all the volcanoes that have been going off for the past week. You see you have one in the Mediterranean basin and then several going around the Pacific. I wonder if that's going to mean anything. Let's see. And so if you look, it gives you the names of several of the volcanoes that have been going off. Okay, so there you have the activity for the week of the 6th through the 20th, through the 12th in 2020. Okay. And it gives you information about whether it's been ongoing or it's a new eruption or things like that. Okay, and so you see from all over the world. Once again, if you want the website, there it is. All right, so if we're going to talk about volcanoes, we obviously have to talk about lava and magma. Now remember, magma is liquid rock or partially molten rock that is below the Earth's surface. Lava is once it escapes from the vent or through the vent through a volcanic fissure. Okay, so magma is created when you get the partial melting of peridotite. Remember we talked about that. That's the main ingredient in the mantle. Okay, and that partial melting, not all of it, but part of it melts and becomes basaltic magma. All magma usually starts off as basaltic and then stuff gets added to it in the lower crust. As that magma forms, it has a lower density than the rock around it, so it moves upwards towards the crust, looking for a weak spot. If it manages to find a weak spot, it can come out. So if you're looking at the picture in front of you right now, you'll see you have the asthenosphere down at the bottom, okay, where you have this partial melting, and then the magma, you see it rises up until it ponds, okay, it makes a puddle, a large area right there, okay, and then as that goes up, sometimes different things can happen, and you can get, this is where you get your felsics or your andesitic or things like that, and those will eventually work their way up. They will collect into a magma chamber, and if that magma chamber can find a crack in the Earth's crust, eventually you can get a volcano that forms. Now, when we talk about magma, okay, the composition of the magma is going to affect the properties of that magma. What are we talking about? When we talk about composition, we're primarily talking about silica content. Okay, so in the chart you see before you now, you see you have mafic, andesitic, and felsic. These are terms that we talked about when we talked about igneous rocks, which makes sense because igneous rocks form from magma. Okay, and you see as the silica content goes up, you have different things that happen. One of the main things you happen is this change in viscosity. Viscosiness is basically the stickiness or the thickness of the magma. Okay, a mafic lava doesn't have a lot of silica and therefore is not very thick. The silica makes the magma thick, and so it has a low viscosity. The intermediate has about 60% silica content and its viscosity is in the middle, and felsic lava is incredibly thick. This also affects how it flows. Low viscosity things tend to flow easy. High viscosity things tend to be like cold pancake syrup or honey. Very thick, very difficult to flow. The other difference is the amount of gas that we have in you. The amount of gas that's dissolved, and we'll talk about what that is in a minute, is going to dramatically affect the explosiveness and the violence of the eruptions. Mafic lava has a low gas content, whereas felsic lava tends to have a much, much higher. So mafics are going to be gentle eruptions, and felsics are going to tend to be much more violent. So like we were talking about, you have different types of eruptions, what we call the nature of eruptions. And what we're basically talking about is how explosive is the eruption, the event of the magma escaping, becoming lava from the volcano. Now, if you look at the pictures in front of you, you'll actually see two volcanic eruptions. One is much more explosive and deadly than the other. The one on the left-hand side with the helicopter, you go, oh my God, that looks so bad. It's actually not that bad. That is a relatively mild basaltic eruption. Okay, you do get the gases that expand quickly when they hit the atmosphere, which is why you have the lava fountain. But if you look at the actual lava flowing out of it, it just kind of looks like a very hot river of lava floating in front of you. Whereas the one on the right-hand side, you've got a cloud with lightning in it. If that's not scary enough, you've got lava underneath it. And does it look like that's moving very quickly? No. Why? Because this is probably a felsic eruption with incredibly thick lava, which will create an incredibly huge amount of buildup of pressure, which could be incredibly damaging and dangerous. When a volcano erupts, regardless of the type of eruption it has, it usually releases three things. The first thing is lava, magma, which we just talked about. The second thing is solid particles, which we usually refer to as tephra, T-E-P-H-R-A. And the last are volcanic gases. Now, when we're talking about tephra are solid particles that are released by the volcano as it erupts. If you're looking at the picture in front of you, you can see the different sizes of tephra. So we have what we call volcanic bombs, which are large objects. Okay, lapilli, which are sometimes referred to as cinders. They're smaller little pebbles. We have volcanic ash and volcanic dust, both very, very fine particles, which can be carried very, very far in the air. Now, these guys will typically create what we call volcanic deposits. They can build up the mountain themselves over time, okay, or they can spread far and wide and give us evidence to volcanic eruptions happening over a wide area, okay, many, many millions, if not billions of years into the past. In terms of the gases that are released by a volcano, well, those gases are primarily placed there by confining pressure, okay? As the rock gets pushed below the surface and melts, it's going to contain different substances, different gases, and those gases kind of get held in the lava, in the magma, by the pressure of all the rock around it. Now, once the volcano erupts, that pressure on top gets released, and so the gases are going to naturally go from where there's a lot of pressure to there's not as much, and they're going to escape outwards. Typically, this is what causes eruptions to be explosive, because as the gas leaves, it expands, and it causes the material that it's traveling through to expand, and it explodes. Think of a closed soda bottle that you completely shook up. Now, that gas, you can't really see it. It's held in place by the side of the bottle. The second you twist off the top, it explodes outwards. Why? Because the gas explodes out and it carries some of the liquid with it. Lava basically behaves the same way. That's what's happening in the picture over here. This was underneath the ground and it probably looked very similar to this, but it had a lot of gas in it. And what happened is when it came out, the gas expanded out and it exploded, which is why you get that lava fountain over there. Now, your main gases when we're talking about volcanic eruptions are water vapor, carbon dioxide, and hydrogen sulfide. And then you have other things like sulfuric dioxide, you have some carbon monoxide and things like that. But these two are really important, along with that one being your third. Okay, water vapor and carbon dioxide are your two big gases that are removed. And so when you see a volcano kind of puffing away like this, when you've seen pictures, this is a white cloud. That's mostly what? That's going to be mostly water vapor. So a lot of water vapor is being released by this particular one. It's steam coming out of there. Okay, that's typically what's going to happen. Now, these gases, we think of them, oh, they're gases, they're fine. They can actually be quite deadly. For example, in August of 1986, at Lake Nyos, which was a lake in Cameroon, the gases from a volcanic eruption caused a huge amount of death and destruction. Now, let me set the stage for you a little bit. Lake Nyos, like I said, is a beautiful lake in Cameroon. It looks like this. Very beautiful, very picturesque. This picture was taken probably prior to the 1986 eruption. Okay, very beautiful, lots of fish, lots of animals living in there. It's at the top of a mountain, on the sides, the slopes of the mountains. If you went down, there's beautiful little valleys with lots of little farming villages. In August of 1986, there was a series of earthquakes in the area. The area is known for being volcanic. Okay, and from one day, Lake Nyos went from looking like this, the picture that you see right here, to looking like this. This is the same lake, slightly different perspective, but the same lake. What happened here is what we call an algae bloom. Okay, you had a massive change in the flora of the lake. What that means is that you had this massive increase in the rate of one particular species of plant life, which created a very different color and changed the entire chemistry of the lake. Now, why is that important? Why do we care? Well, because what actually happened here was not just that the lake changed color, but on the sides of the lake, remember those little villages we talked about? Well, about 1,500 people lost their lives. How did that happen? Because what this is this is not just a lake. This is what we call a crater lake. And what a crater lake is, this used to be the opening of a volcano. And it filled in with water. But the vent was still down below. And coming out of that vent was a huge amount of carbon dioxide. And that carbon dioxide was building up at the bottom of this lake. Now, what we think happened, what scientists have inferred is to happening, is that you had this carbon dioxide coming out from these underground volcanic chimneys dissolved into the lake. And it just kind of sat there because carbon dioxide is a relatively heavy gas. But those earthquakes that I just talked about sloshed the water around. And when it sloshed the water around, a big bubble of carbon dioxide rose up to the surface, popped. Now, since carbon dioxide is heavier than water, that carbon dioxide flowed down the side and hung in the village. And basically what happened is it just asphyxiated. It choked everybody out. Okay? And people who were asleep just fell, it's like carbon monoxide poisoning. It's carbon dioxide poisoning, but the same basic thing. They could not breathe, they died. And when some people went by the village the day after this happened, they were surprised because there were no sounds, no animals, no children, no people talking, babies crying, anything. It was completely quiet. In fact, there were no cows mooing. These places had lots of livestock. And what they found was this. This picture represents livestock that were killed as that carbon dioxide just raced down the side of the mountain and basically asphyxiated every living thing that it came in contact with. It killed 1,500 people and over 3,500 livestock. It was one of the greatest disasters, and nobody knew what happened until they investigated the lake and figured it out. Now, what we found is that there are a lot of other volcanic lakes and places like that that have these bubbles. So one of the big things now, one of the engineering things happening in places like Cameroon, Tanzania, and other places around the world is figuring out how we can safely get that carbon dioxide out of the water into the atmosphere without having this same basic effect happening, killing a whole bunch of people. Now, something that can happen is the tephra and the gases that we were talking about can actually combine, and they can make what we call a pyroclastic flow, or the French term nuée ardente. Okay, and what a pyroclastic flow is, it's basically a huge amount of ejected material, so that's the tephra, mixed with the superheated gases, which we just talked about, pulled down by gravity along the slopes of the volcano. So basically what happens is you get an eruption like this, big mushroom cloud happens. Now, there's a lot of energy pushing that stuff up. But the problem is that energy is going to push it up, push it up, push it up, but eventually gravity is going to win. And what can happen is that column just collapses and races down the side of the volcano. Now, it races down the side of the volcano, but it's got kind of a layer of gas underneath it right here, which kind of keeps it off the ground, and so it makes it travel super, super, super fast. And this can race down the side of the mountain incredibly quickly and engulf anything that's living there, like people. Like that truck you see right there. And so what can happen is these massive pyroclastic flows can cause all sorts of death and devastation incredibly quickly. One of the most famous examples of this was in Pompeii. You guys have seen this. In Italy, there's a volcano called Vesuvius, and the people of that city and Herculaneum, which is a city relatively close to them, were devastated by this eruption early in the first millennium. They were caught, and you can see these people were caught in their sleep. And a pyroclastic flow basically raced down the side of the mountain and caught them and killed them and encased them in ash and dust where they slept. And so you have these bodies that were discovered hundreds of years later in the same exact position in which they died. The last thing we want to talk about is global volcanic activity. We kind of talked about it at the beginning. Most volcanic activity on Earth tends to happen around the edges of the oceanic plates, like we talked about oceanic plates earlier in this unit. Now, there's two main areas where this happens. One is around the Mediterranean Ocean, and the other one's around the Pacific, what we call the Ring of Fire. You do have other events that happen, and those happen at what we call hotspots, places like Hawaii and things like that. All right, guys, so that does it for volcanoes. The assignment that you're getting tonight will actually be counted as a lab, so please make sure that you put it in on turnitin.com. It will count towards that portion of your grade, so please make sure it's done. And I hope you guys learned. If you have any other questions, feel free to email me or anything like that. I got plenty of videos and stuff on volcanoes. I just couldn't include it all in this video. Alright guys, see you later. Bye.